Hello everyone, let's take a look at our next problem. So this one, straightforward calculus, just says integrate and differentiate x ln x. So the differentiation should be pretty straightforward, nothing other than straightforward application of rules of differentiation. To integrate, my first instinct is integration by parts, because I have something I know how to differentiate multiplied by something I know how to integrate, and by taking a derivative of this, it becomes more basic in some sense. Well, let's differentiate first, get that one out of the way. So this is just product rule, right? I have the derivative of x multiplied by log x, that's this, and the derivative of log x multiplied by x. The derivative of log x is 1 over x, so there we go. Integrating. So like I said, the first thing I'm going to try is to do this by parts. I'll let u equal x, so that du is equal to dx. And then dv is log x dx. I did this, I had this backwards in my head. The integral of log x is not obvious, but I happen to know just from previous experience that the integral of log x is x log x minus x. Okay, so how do I know that? Well, we can check directly, right? If I take a derivative of this, well, you'll notice that this part here is the original function that we started with, x log x, right? So the derivative of this, we've already done, it's log x plus 1. And then when I subtract x, I get, I'll be subtracting this 1. So I know that the derivative of this here is log x, okay? Maybe at the end of this I can discuss some techniques of integration that allow us to actually figure that out directly rather than just happening to have knowing it beforehand. Okay, so what is this integral equal to? It'll be equal to uv minus the integral of v du. So this is x times x log x minus x minus the integral of x log x minus x dx. All right, so let's expand this part at the beginning. I'm going to write this integral in two parts. I have minus the integral of x log x dx plus the integral of x dx. So the first thing I'm noticing, this integral is the thing we're actually trying to solve for, right? So it looks like perhaps we're going in circles. But what I'm going to do is I'm going to call this integral that we're trying to solve for I. So what I have here is I is equal to x squared log x minus x squared minus I plus, and I can do this integral directly, that's just going to be x squared over 2. Let's put our constant of integration in here now. And what I'll do is I will bring this appearance of I to the other side of the equation. So I now have 2I is equal to x squared log x minus x squared over 2 plus c. So I've combined two of these terms here. And so I is equal to x squared log x over 2 minus x squared over 4 plus a different constant of integration. And we should be able to check our answer, right? We now have I. We have I as a function of x up to an arbitrary constant. If we differentiate this, we should get the original function back, right? So let's just compute I prime. Make sure we've got things going correctly here. This should be straightforward. Just applying some rules of derivatives here. Okay, so I have x log x plus x over 2. That's the derivative of that whole thing using some product rule, minus x over 2, which is x log x. Okay, so we did this correctly. When we take a derivative of this result, we get back the original function we had, so we know this is correct. Okay, so the only sort of outstanding piece of work here is how did I know that the integral of log x is x log x other than just a guess and check, right? If you take a derivative of this, you'll get log x back. Maybe I can just work through quickly applying a technique to computing this. I suspect we might actually have something similar going on here. So I'll say j is equal to log x. I'm going to use integration by parts again. Do I want to use integration by parts? What do I want to do here? Yeah, so I'm going to say that u is equal to log x. So then du is equal to 1 over x dx. And dv is simply equal to dx, so v is equal to x. And I'll use my integration by parts with those two substitutions, so that j is uv minus the integral of v du. So u times v is x log x. Integral of x du is 1 over x dx, so I have some simple cancellation here. So j is equal to x log x minus the integral of 1 dx is just x, and I suppose I should have a constant of integration at this point floating around, but we didn't need that constant of integration when you do the integration by parts here. And make the step from dv into v. You can add a constant of integration if you want, but it won't affect the final result. Yeah, so that's a neat little problem. Nothing more than applying rules of differentiation and recognizing in my original function that I have a product of something I can differentiate and something I can integrate, and then just going ahead and making the integration by parts substitution. Good problem.